Hello there. Welcome to Depths of Unknown. There is a sea in the far north of the Pacific Ocean that exists at the intersection of two continents, two oceans, two climates, and two entirely different ways of understanding what it means to make a living from the water. The Bering Sea lies between Alaska and Russia, between the Arctic and the Pacific, between the world of ice and the world of open ocean, and it is a place whose extremity is not metaphorical. The cold is genuine. The storms are genuine. The waves that build across its shallow continental shelf and break over the working decks of fishing vessels in the darkness of an Alaskan winter are genuine. The Bering Sea is approximately 2.3 million square kilometers of subarctic water that freezes at its northern margins every winter, retreats every summer, and in between generates some of the most violent weather conditions on the surface of the planet. It has been called the most dangerous body of water in the northern hemisphere. It has been called the most productive fishing ground on Earth. Both of these things are true, and they are not coincidences. The same conditions that make the Bering Sea so dangerous, the cold, the storms, the shallow shelf that turns long ocean swells into steep breaking waves, are the same conditions that make it so extraordinarily productive. The sea is dangerous because of what it is, and what it is also happens to be one of the great engines of marine biological productivity on the planet, a ecosystem so rich in nutrients and in life that it feeds not only the fish and the seabirds and the marine mammals of the North Pacific, but a substantial fraction of the seafood consumed by human beings across the entire world. The geography of the Bering Sea is defined by the shallow continental shelf that extends beneath most of its area, the narrow passages that connect it to the Arctic Ocean to the north and the Pacific Ocean to the south, and the land masses that surround it on three sides. To the east, Alaska extends from the Arctic coast down to the Alaska Peninsula and the Aleutian Islands. The 1,000-kilometer chain of volcanic islands that forms the southern boundary of the Bering Sea and separates it from the open North Pacific. To the west, the Russian Far East, specifically the Kamchatka Peninsula and the Chukotka region, defines the western boundary. To the north, the Bering Strait, the 55-mile wide, only 47 meters deep passage between Alaska and Russia, connects the Bering Sea to the Chukchi Sea and the broader Arctic Ocean. The shallowness of the Bering Sea's continental shelf is perhaps its most important physical characteristic. The eastern Bering Sea shelf, one of the largest continental shelves in the world, has an average depth of only about 70 meters, shallow enough that ocean swells generated by the intense storm systems that track across the Aleutian Islands are compressed as they move onto the shelf and become steeper, shorter, and more powerful. This compression of wave energy onto the shallow shelf is what produces the characteristic steep and breaking sea conditions that fishermen know as the worst the Bering Sea can offer. Not simply large waves, but short, steep breaking waves that arrive from multiple directions and that can overwhelm a vessel far more efficiently than the longer, more predictable swells of the deep open ocean. The weather systems that generate the Bering Sea's notorious winter storms arise primarily in the Gulf of Alaska and track westward along the Aleutian Island chain, deepening as they go and producing some of the most intense extratropical cyclones, low-pressure system, in the Northern Hemisphere. These storms generate sustained winds that can exceed 100 kilometers per hour and gusts that exceed 150, producing waves in the open Bering Sea that can reach 12 to 15 meters and occasionally more. The shallow shelf amplifies these waves, compressing the wave height into a shorter period and a steeper face, and the combination of extreme cold, air temperatures that can fall to -20 degrees Celsius or colder during winter storms, and salt spray produces ice accumulation on ship decks and rigging and structures that is one of the specific hazards of Bering Sea fishing. When seawater spray freezes on a vessel's superstructure, it accumulates as ice that raises the center of gravity of the ship, reducing its stability and its ability to self-right after a roll in heavy seas. Crews in the Bering Sea must chip ice continuously during winter storms, working on exposed decks in conditions of extreme cold and violent motion, removing ice by hand and with tools to prevent the accumulation that can capsize a vessel that is already operating at the edge of its stability limits. A vessel that loses the battle against ice accumulation does not simply become uncomfortable. It becomes a vessel that can no longer right itself after a roll, a vessel that, when the next large wave breaks over it, may not come back. This is the specific mechanism by which the Bering Sea has taken vessels that were otherwise sound and seaworthy, and the simplicity of the mechanism, ice, cold, spray, gravity, makes it no less lethal for being well understood. The biological richness of the Bering Sea is a consequence of oceanographic processes that convert the physical characteristics of the sea. Its shallowness, its cold, its seasonal ice, and its position at the junction of Arctic and Pacific water masses, into an extraordinary supply of nutrients that drives one of the most productive marine ecosystems on Earth. The continental shelf of the eastern Bering Sea is characterized by the seasonal cycle of primary production that begins when the sea ice retreats northward in spring and the open water is exposed to the increasing solar radiation of the Arctic spring. As the ice retreats, it leaves behind a meltwater lens of cold, fresh, nutrient-rich water at the surface, and the ice edge bloom, one of the most intense phytoplankton blooms in the world ocean, occurs as the phytoplankton in this meltwater layer explode in growth, fueled by the nutrients brought up from depth during the winter mixing and by the spring light. This ice edge bloom is so intense that it can be seen from satellites as a vivid green band following the retreating ice margin northward across the shelf. And the carbon it fixes in the brief weeks of its peak production forms the foundation of a food web that extends from microscopic zooplankton to the blue whale, one of the largest animals that has ever lived. The intensity of this bloom and the richness of the Bering Sea shelf ecosystem that it initiates are among the reasons the Bering Sea supports the largest population of northern fur seals in the world, the largest population of stellar sea lions, enormous colonies of seabirds, murres, puffins, kittiwakes, fulmars, auklets, and the fish populations that make it one of the most commercially important fishing grounds on the planet. Or the fish of the Bering Sea constitute a resource of global significance that places the sea at the center of commercial fishing in a way that is difficult to overstate. The Alaska pollock fishery in the Bering Sea is the largest single-species commercial fishery in the world by volume, producing approximately 1.5 million tons of fish per year at its productive peaks. Alaska pollock is the fish in most fast food fish sandwiches served in the United States and in much of the developed world. The fish used in surimi, processed fish products sold globally, and one of the most important protein sources in the human food system. The Bering Sea also supports major commercial fisheries for Pacific cod, Pacific halibut, yellowfin sole, and other flatfish species, and the crab fisheries that have made the sea famous in popular culture: the red king crab, the blue king crab, the snow crab, and the tanner crab, harvested in the winter months by fishing vessels that represent some of the most dangerous working environments on the planet. The crab fisheries of the Bering Sea have historically operated under quota systems designed to prevent the collapse that has characterized commercial fisheries in many other parts of the world. But the population dynamics of Bering Sea crab species have proven sensitive to climate variability, and the dramatic fluctuations in crab abundance that have occurred in recent decades have had severe economic consequences for the fishing communities of Alaska. The crab fisheries of the Bering Sea, specifically the red king crab and snow crab fisheries, operated from the port of Dutch Harbor on Unalaska Island in the Aleutian chain, became the subject of the American documentary television series Deadliest Catch, which began airing in 2005 and brought the realities of Bering Sea fishing to a global audience that had little direct knowledge of the conditions under which the fish on their tables was harvested. The series follows crab fishing vessels operating in the Bering Sea during the winter crab seasons, and its impact on public awareness of commercial fishing conditions has been substantial. It has given millions of people their first genuine understanding of what it means to set crab pots in the Bering Sea in January, in the darkness, in conditions that are trying to kill you, for wages that are contingent on whether the crabs are there. The name the series chose for itself was not promotional exaggeration. Commercial fishing in the Bering Sea has historically recorded fatality rates that make it one of the most dangerous occupations on Earth. Fatality rates multiple times higher than those of mining, logging, or construction, the industries that are typically cited as the most dangerous on land. The vessels are small relative to the sea conditions they operate in. The work is physically demanding and conducted on wet and icy and moving surfaces in extreme cold. The hours are long. The financial pressures to keep fishing through deteriorating conditions are intense. And the distance from emergency services in the event of a catastrophic failure is measured in hours of helicopter or Coast Guard cutter transit time across some of the most hostile water in the Northern Hemisphere. The United States Coast Guard station at Kodiak, which is responsible for search and rescue in the Bering Sea, has conducted some of the most technically demanding rescue operations in maritime history in these conditions, operations in which the rescuers themselves operate at the edge of survival. The people who have fished the Bering Sea and lived alongside it stretch back far beyond the era of commercial fishing and the documentary cameras. The indigenous peoples of the Bering Sea region, the Yupik of Alaska and the Siberian Yupik, the Unangan people of the Aleutian Islands, the Alutiiq, the Kupik, the Inupiaq of the northern coast, have lived in relationship with this sea for thousands of years, developing the technologies, the ecological knowledge, and the cultural practices that made permanent human habitation of one of the harshest environments on Earth not merely possible, but rich and complex and deeply sustained. The Unangan people of the Aleutian Islands, whose territory extended along the entire southern edge of the Bering Sea for over 1,000 kilometers, developed the Baidarka, a skin-covered kayak of extraordinary hydrodynamic sophistication, capable of operating in the rough coastal waters of the Aleutian chain with a maneuverability and seaworthiness that European explorers and scientists consistently described as remarkable. The Baidarka's bifurcated bow, its flexible frame that moved with rather than against the water, and its paddler's ability to roll and recover from capsizes in water at near freezing temperatures represented a solution to the problem of sea travel in the Bering Sea that was in many respects more elegant and more adapted to the actual conditions than the European vessels that arrived centuries later. Their knowledge of the Bering Sea's weather, its seasonal patterns, its fish and marine mammal resources, accumulated over thousands of years of sustained observation, represents an archive of ecological and meteorological information about the sea that is only now beginning to be recognized by Western science as a resource of genuine scientific value alongside the data produced by modern instruments. The Bering Sea's role in Earth's history extends to one of the most significant episodes in human prehistory: the peopling of the Americas. During the last ice age, when sea level was approximately 120 meters lower than it is today, the shallow Bering Strait and the broad continental shelf of the Bering Sea were dry land, a landmass connecting Asia and North America that geologists call Beringia, a landscape of tundra and steppe grassland that extended for approximately 1,500 kilometers from north to south and that supported populations of mammoths, horses, woolly rhinoceros, bison, and the other megafauna of the Pleistocene. The human populations that crossed Beringia, moving from Northeast Asia into North America sometime between 20,000 and 15,000 years ago, or in the most consequential human migration in the history of the Americas, walked across what is now the floor of the Bering Sea, through the shallows and river valleys of an exposed landscape whose outline can still be read in the bathymetry of the modern sea. The ancient river channels of Beringia are visible on seafloor maps as depressions in the continental shelf, and the bones of the megafauna that those first Americans hunted have been dredged from the shallow Bering Sea floor by commercial fishing vessels and recovered by scientific expeditions. The sea that is now the Bering Sea was the land bridge that made the Americas human, and the shallows in which crab pots are set and trawl nets drag today are the drowned valleys and grasslands of a world that existed before the ice melted and the ocean returned. What the Bering Sea ultimately is, considered whole, is an argument against simplicity. It is simultaneously the most dangerous and the most productive. It is simultaneously ancient, the floor of a land bridge walked by the first Americans, and urgently contemporary, the site of climate changes that are altering the timing and extent of sea ice, shifting the distribution of fish populations, and threatening the communities that have built their lives around its resources for generations. The Bering Sea is warming faster than almost any other body of ocean water on the planet, and the sea ice that once formed predictably each winter and retreated predictably each spring is now forming later, retreating earlier and covering less area than at any time in the observational record. The consequences for the ice-dependent ecosystems, for the ice algae that anchor the food web, for the walrus populations that depend on sea ice as a resting platform during their migrations, for the species that depend on ice for breeding and resting and hunting, are already measurable and are projected to intensify as the Arctic continues to warm at rates that exceed the global average. The pollock and cod and crab populations of the Bering Sea are shifting northward as the water warms, moving into the Russian exclusive economic zone and into shallower Arctic waters that have not historically supported commercial-scale fishing, reorganizing the geopolitics and the ecology of the sea simultaneously. The roughest sea in the northern hemisphere is also one of the most sensitive to the changes being made to the climate that drives it. And the fishermen of Dutch Harbour, the indigenous communities of the Aleutian coast, the seabirds and whales and seals and fish, they are all, in their different ways, watching to see what the sea becomes. The Bering Sea does not stay still. It never has. The question is only whether the changes coming now are arriving faster than the systems built across thousands of years of relationship with this water can absorb and adapt to and survive.